So here's my equilateral triangle. Class, this angle down here would be what? 60. How about this one up here? Now together it would be 60, but this here, this line, back in geometry they call this one the perpendicular bisector. So x is going to be equal to 30 degrees. Now, if you look at our equilateral triangle, all sides are congruent. And this side as well is congruent. So if this side is 2, this one is 2, then the whole length is 2. That means if you put them in congruent parts, this would be 1, and z is equal to 1. Now the y variable was meant to be this side here. So if you take this triangle now, if you have a lot of things on there, you can just redraw that triangle. Let's do that. So now I have a 30. Now I have a 30, 60, 90. This is 2 and this is 1. And then I can just use Pythagorean theorem to solve for the third side. So Pythagorean theorem. Partner B tell partner A the Pythagorean theorem. Ready, set, go. Edwin? Shh. Edwin? Now, class, do you see a circle? There is no circle on our triangle, so you could use this, but I would recommend not using it. I'd probably use the other form of the Pythagorean theorem. Edwin, what is that? Tell your partner what is the most important letter. Crystal, which one is the most important letter? Yeah, that C part. So that's our C. Crystal, A or B? And this one? Yeah, doesn't really matter. So I have 2 squared equals 1 squared. And our B value up here we had called Y. Do you guys see that? So essentially what we're doing is we're finding the length of Y. Class 2 squared is 1 squared. How do you solve for Y? Subtract 1 from both sides. Now what? Remember, you're only taking the positive. Y is equal to the square root of 3. Raise your hand if you got that. So let's add that up here. Y is equal to the square root of 3. So in this problem, we have not used officially our trig ratios yet to solve for sides and angles. But we can take a 30, 60, 90 and just make it an equilateral triangle and then use Pythagorean theorem to solve our sides and angles.